There is something following Earth, not a myth, not a theory, a real, physical object, moving in tandem with our planet, locked in a gravitational dance that has, until recently, gone largely unnoticed. To the untrained eye, space seems empty, vast and unchanging. But for those watching closely, there are subtle patterns, strange orbital echoes, and anomalies that whisper of hidden presences just beyond our sightline. And now, scientists are finally paying attention. The first clue came not from a telescope, but from patterns. Orbital simulations, to be exact. In the early 2000s, astronomers noticed that small bodies in the solar system, particularly near-Earth asteroids, were behaving oddly. Not quite following the standard chaotic trajectories of random space rocks, but not orbiting in neat, predictable ellipses either. They were doing something different. One of these anomalies was 3753 Cruithne, often dubbed Earth's second moon, although it doesn't orbit Earth directly. Instead, it follows a horseshoe-shaped orbit that keeps it gravitationally entwined with our planet. At times, it leads Earth in its orbit. At other times, it trails behind, like a ghost companion dancing around our path through the solar system. It's not a moon in the traditional sense. It orbits the Sun, not Earth, but its synchronized motion makes it something more than just another asteroid. Cruithne is just the beginning. In recent years, a number of co-orbital objects have been identified: Trojans, quasi-satellites, and even potential Kordylewski clouds. These are not science fiction. These are confirmed celestial structures that share Earth's orbital path in complex, often beautiful, orbital relationships. And among them, one has stood out. Enter 2016 HO3. Discovered by the Pan-STARRS-1 asteroid survey telescope in Hawaii, 2016 HO3 is what scientists call a quasi-satellite. It is one of the most stable quasi-satellites of Earth that we've ever found. Roughly 40 to 100 meters in diameter, this object is not large by planetary standards. It would fit comfortably inside a football stadium. But in orbital mechanics, size isn't everything. Behavior is. This rock has been in a locked dance with Earth for at least a century, and is expected to remain so for hundreds more. It loops around Earth as it orbits the Sun, staying between 38 to 100 times the distance of our Moon. It doesn't orbit Earth directly, but Earth's gravity shapes its path. It's a gravitational prisoner on a long leash. From our point of view, 2016 HO3 seems to orbit backward around Earth once a year. But this is an illusion caused by the overlapping orbits of Earth and the object. Its actual path is like a lopsided ring that stretches behind and ahead of us. A cosmic tether of sorts. It never strays too far, never gets too close. It simply follows. Why is this important? Because for decades, we assumed that Earth had just one natural satellite, the Moon. But in truth, our planet is surrounded by a web of temporary companions, orbital hitchhikers that tag along for thousands, even millions of years. Some are dust clouds, like the elusive Kordylewski clouds at Earth's L4 and L5 Lagrange points, regions of gravitational balance where dust may collect and remain stable. These clouds, predicted in the 1960s, were only directly confirmed in recent years using polarizing filters to detect their faint scattered light. Others are small rocks, like 2023 FW13, a newly observed quasi-satellite discovered in 2023 that has followed Earth since at least 100 BC and will likely continue until 3700 AD. The stability of its orbit is astonishing. It doesn't just accompany Earth, it mirrors our planetary rhythm across millennia, as if choreographed by some cosmic intelligence. The existence of such companions raises profound questions. How many of these objects are out there, just beyond our perception? Could some be artificial? Could they harbor scientific clues about the early solar system? Are they a threat or an opportunity? Astronomers are paying attention not just because of the novelty, but because of what these objects reveal about gravitational mechanics and about Earth's place in the celestial order. Co-orbital bodies are natural laboratories. They allow us to study gravitational interactions, solar radiation effects, and orbital resonance in real time. They also provide potential waypoints for future space missions, stepping stones to deeper space that already follow our path. But there's another layer to this mystery, something more recent, more intriguing. A 2024 study using data from the Gaia Observatory and ground-based optical sensors has revealed anomalous infrared emissions trailing slightly behind Earth's orbit. The signal doesn't match any known catalogued asteroid. It appears faint but consistent. It reflects light irregularly, and it shows slight deviations in movement that hint at either a tumbling body or an object with dynamic surface changes, possibly artificial. Speculation followed quickly. Could this be space debris? Unlikely. Its orbit is far too stable. Could it be a defunct satellite? Too large and outside our typical orbital range? Could it be a new type of quasi-satellite or something entirely unclassified? NASA and ESA have both remained measured in their public statements, labeling it a candidate co-orbital anomaly. But the silence has fueled interest. What was first thought to be noise in the data is now being tracked, coordinated through multiple observatories. Preliminary estimates suggest it may be larger than 2016 HO3, potentially hundreds of meters across. But its exact shape and composition are still unknown. And then came the radar bounce. Arecibo is no longer operational, but its legacy lives on in a global network of radar facilities. One such facility, part of the Goldstone Deep Space Communications Complex, recently conducted a radar ping on the anomaly. The result was a partial return, weak, distorted, but unmistakably artificial in profile. Not natural spherical scattering, not rough rock. Something structured. Suddenly, scientists were no longer talking about an asteroid or a cloud. They were using terms like complex reflectivity signature and non-stochastic return curve. In plain English, whatever this is, it might not be a rock. It might be engineered. Let's be clear, that doesn't mean aliens. There are dozens of reasons a human-made object could end up in a strange orbit. From early mission stages lost to time, to Cold War relics, to unknown classified projects. But the size, the location, and the lack of any historical launch record matching this trajectory complicates the explanation. We've spent decades scanning deep space, peering into the edges of the observable universe, but perhaps we've missed something closer to home, something shadowing us, mimicking our motion, slipping through the gaps of our attention. This revelation has opened the floodgates. What else is out there, riding Earth's orbit like a stowaway? Are these ancient travelers, natural artifacts, something else entirely? Our planet does not move through space alone. We are accompanied by rocks, dust, perhaps even by engineered machines. And as we refine our sensors, build better telescopes, and develop deeper algorithms to mine the data, more of these companions are coming into focus. They have always been there. We simply weren't looking closely enough. And what we're finding now is changing our understanding not only of Earth's neighborhood, but of how cosmic objects interact with each other, how patterns persist over eons, and how deeply the solar system still hides its secrets in plain sight. Earth's path around the Sun is not an empty road. It's a corridor, a gravitational channel shaped by billions of years of cosmic motion. Invisible forces are at work here, not just gravity, but solar wind, radiation pressure, and the orbital momentum of countless other objects. Our planet doesn't simply trace a neat ellipse through the void, it moves through a crowded, dynamic web of resonances, echoes, and ephemeral companions. To understand what might be following us, we need to understand the architecture of orbital space. There are 5 points in space where gravitational forces and orbital motion balance in such a way that objects can remain relatively stationary with respect to Earth and the Sun. These are the Lagrange points, L1 through L5, and they form the hidden scaffolding of our planet's orbital environment. L1 lies between Earth and the Sun and is home to satellites like the Solar and Heliospheric Observatory, SOHO. L2 sits on the opposite side of Earth, ideal for deep space telescopes like the James Webb Space Telescope. But it's L4 and L5 that intrigue us most here. These points form equilateral triangles with Earth and the Sun and lead and trail Earth in its orbit by 60 degrees. They're stable, meaning dust, rocks, and even spacecraft can linger there for millennia. Think of them as gravitational eddies, where cosmic debris can swirl and gather without being swept away. And this is where things start to get strange. In 2019, researchers using high-sensitivity polarization detectors confirmed something long theorized but never directly observed: enormous clouds of dust occupying the L4 and L5 points of Earth's orbit. These are the Kordylewski clouds, vast, faint aggregations of microparticles trapped in Earth's gravity wells. They're ethereal, nearly invisible to the naked eye, but they exist. These clouds don't follow Earth in the same way as quasi-satellites, but they do mirror our orbit, maintaining fixed positions relative to Earth and the Sun. They're like soft, ghostly shadows cast across the cosmos. But what else might be lurking in these gravitationally stable zones? In 2022, the Gaia Space Observatory, best known for mapping the positions and motions of over 1 billion stars, detected a thermal anomaly in the vicinity of Earth's L5 point. The data was subtle, buried in noise, but persistent. A slow, consistent infrared signature, warmer than expected for dust and spatially distinct. Follow-up observations by the Subaru telescope in Hawaii and the Very Large Telescope in Chile revealed something remarkable: a low albedo object with unusual reflective behavior. Its brightness shifted unpredictably, suggesting surface irregularities or rotational movement. It did not behave like a natural asteroid or a dust cloud. Its orbit was equally bizarre. It was not fully bound to the L5 point, but it lingered near it, loosely tethered like a kite at the edge of a string. Analysts compared its behavior to a halo orbit, but with irregular perturbations that defied easy classification. For months, it was dubbed Object L5X. Quietly, astronomers began compiling spectral data, comparing its reflectance with known materials. Early estimates hinted at a surface at least partially metallic, not highly reflective like aluminum, but something more akin to titanium oxide or weathered composite alloys, materials more common in engineering than in nature. Object L5X became a quiet obsession in astronomical circles. Papers were drafted, hypotheses floated. Could this be a natural metallic asteroid caught in Earth's Lagrange zone, a relic from the early solar system, or, the bolder theory, a piece of space technology, not necessarily alien, but perhaps ancient? Our solar system is over 4.5 billion years old. Civilization, by contrast, is less than 10,000 years old. If intelligent life ever arose elsewhere in the galaxy, even just once, the odds are high that it predates us by millions of years. In cosmic terms, any civilization older than us by even a few 100,000 years could have sent probes, uncrewed, automated observers, to study emerging biospheres across the galaxy. Earth, with its persistent spectral fingerprint of oxygen, water vapor, and methane, has stood out as a biosphere for over 2 billion years. It wouldn't be surprising if it had attracted attention. This is the basis of the Lurker hypothesis, a fringe yet growing scientific theory that suggests alien probes may be hiding in stable orbits near Earth, quietly observing, undetected due to our limited technology or assumptions. The L4 and L5 points are natural hiding places. They offer gravitational stability, shielding from detection, and persistent proximity to Earth. A probe placed there would require minimal energy to remain stationary. It would also avoid the electromagnetic noise and debris that clutter Earth's immediate vicinity. So when object L5X was detected, the theory gained new momentum. Was it a piece of space debris from an unrecorded mission, a chunk of asteroid, or something more intentional? Radar scans were inconclusive. Its signal was faint, distorted by its distance and orbital positioning. Attempts to image it in the optical spectrum produced a blurry, elongated smear, more indicative of a rotating object than a point source. And then, something changed. In early 2025, the object's position shifted, slightly but measurably. It began drifting from its semi-stable orbit near L5, heading toward a new trajectory that brought it marginally closer to Earth's orbital path. This shift wasn't entirely natural. Simulations suggested it would require a delta V, a change in velocity, of about 10 meters per second. Not a lot in space terms, but far too specific to be a random perturbation. There was no solar storm, no gravitational encounter, nothing that should have nudged the object in that direction, which left scientists with a puzzle. Was it an internal adjustment, a release of stored gas, or an active maneuver? The questions mounted, so did the attention. As it moved, telescopes tracked it relentlessly. Its reflectivity changed. It began flashing faintly, pulses spaced irregularly but statistically significant, not bright enough to be seen without filters, but noticeable against the dark infrared background. It didn't match any known beacon frequency. It didn't repeat like a radio signal, but it pulsed. Not in Morse code, not in binary, not in any human format, but regularly enough to suggest rhythm. Some called it coincidence. Others were less sure. What could be signaling from L5? Was it a reflection, a rotating panel, or was something, or someone, trying to say hello? The science remained cautious. The data, however, was undeniable. A large, structured object, partially metallic, exhibiting non-random movement and anomalous reflectivity, had shifted from a stable gravitational point near Earth and was now tracing a new path. And then came the silence. After several weeks of movement and irregular flashing, the object ceased emitting anything detectable. No flashes, no shifts. It simply resumed a quiet drift, stable once more, unchanging. As if it had reacted, as if it had seen us watching. What could be out there, hiding in the quiet corridors of our orbit? The deeper we look, the more we find. And each discovery only deepens the mystery. There's something haunting about the idea of being followed, not by a person or a predator, but by a silent, drifting object in the void. Something that traces your every move, matching your rhythm so perfectly that you don't even notice it's there. For Earth, this is not fiction, it's a reality playing out across millions of kilometers of space. While current attention has focused on recent anomalies, like Object L5X, and quasi-satellites such as 2016 HO3 and 2023 FW13, the broader pattern is even more mysterious. Earth has accumulated a population of what some scientists now call orbital phantoms, small, obscure objects that appear suddenly in co-orbital configurations, linger for years or centuries, and then disappear. Some of these may be natural, others perhaps not. In 2006, astronomers detected a temporary object in a near-Earth orbit that mimicked the path of our planet so closely that it was initially believed to be artificial. Catalogued as 2006 RH120, this object briefly became a mini-moon, orbiting Earth for several months before escaping back into solar orbit. Its size, about the same as a car, and its low relative speed made many wonder if it was a piece of rocket hardware, perhaps from the Apollo missions or even earlier. But orbital forensics, the process of tracing a space object's trajectory backward through time, found no credible match to any known launch. The object had no paint, no insulation residue, no emissions. It was a silent stone, one that behaved just a little too perfectly to dismiss as coincidence. It's not the only case. Every decade or so, telescopes catch something strange entering Earth's orbital sphere, only to lose track of it days or weeks later. These transient visitors are difficult to study. They often appear at odd angles, dimly lit and fleeting, making detailed observation nearly impossible. Some exhibit odd brightness curves or reflectance spikes, characteristics more common in tumbling spacecraft than in natural asteroids. These orbital ghosts are now the focus of an emerging field: transient orbital anomaly tracking. It's not just about looking for UFOs or debris, it's a genuine scientific effort to understand the unexplained motion of near-Earth bodies. Space isn't empty, it's a sea of subtle interactions, and some of its waves leave strange wakes. And then there are the objects we've found that simply shouldn't exist where they are. Consider the Black Knight. For decades, conspiracy theorists have pointed to this supposed satellite as evidence of alien surveillance. A dark, irregular object allegedly orbiting Earth in a polar path long before we had the technology to put anything there. Most of the claims about the Black Knight are based on misinterpreted photos, radio anomalies, or speculation. And yet, buried in the mythology is a kernel of truth. In 1998, during the STS-88 shuttle mission, astronauts photographed a strange object floating near the spacecraft. Jagged, black, angular. It appeared artificial. NASA later identified it as a piece of thermal blanket lost during a spacewalk. But to this day, many remain unconvinced. The object's geometry, its presence in orbit, and its sudden disappearance fed a wave of speculation. Could an object like the so-called Black Knight be real? Not as a singular alien satellite, perhaps, but as one of many strange, uncatalogued bodies in Earth's gravitational sphere. The deeper issue is this: our ability to track small, dim objects in space is limited. Even today, we can only detect and monitor a tiny fraction of the objects larger than 10 meters that exist in Earth's orbital region. Anything smaller, darker, or more distant, especially those that aren't emitting radio signals, can easily remain hidden. Which raises an important question: what might be hiding just out of view? The Moon itself provides a useful comparison. For years, scientists believed it was a lifeless, inert body. But with newer sensors and instruments, we've discovered that the Moon has a tenuous atmosphere, seismic activity, and even the occasional flash of light. Transient lunar phenomena that remain unexplained to this day. If we were so wrong about something as familiar as our Moon, how much might we be missing in the orbital shadows that follow Earth? As part of a collaborative initiative launched in 2024, NASA, ESA, and Japan's JAXA space agency have begun deploying what they call Lagrange observers, small, autonomous probes that park at Earth's L1, L2, L4, and L5 points. These observers are equipped with high-sensitivity visual, thermal, and radio instruments, scanning constantly for anything that doesn't belong. The data is already producing surprises. One observer stationed near L4 has detected low-frequency radio fluctuations that don't correspond to natural solar or galactic sources. They're subtle, like background chatter in a quiet room, but they repeat with eerie regularity, forming patterns too structured to dismiss as noise. They're not beacons, they're not messages, they're something else, possibly the leakage of a device or an artifact of a rotating surface. The signals rise and fall on a cycle of 13.5 days, coinciding with Earth's orbital progression through a minor gravitational harmonic near L4. What emits low-frequency radio pulses, reflects light like a tumbling alloy, and follows Earth with surgical precision? Scientists aren't making claims yet, but many agree. We've entered a new phase of discovery. Historically, we've looked outward, to the outer planets, to exoplanets, to galaxies. But now, we're realizing that our own orbital path may be rich with undiscovered companions. Some are natural and ancient, others may be engineered, and some may be relics, not of our civilization, but of something far older. The concept of Bracewell probes, theoretical robotic emissaries sent across the galaxy to monitor life-bearing worlds, has long existed in scientific literature. Unlike the dramatic landings of science fiction, these probes would be quiet, passive, and observational. They would not land, interfere, or reveal themselves unless provoked. If such probes exist, they might sit in co-orbital positions, Lagrange points, quasi-satellite orbits, or even Trojan shadows, places where gravitational forces and observational opportunities align perfectly. And if we've finally started to notice them, perhaps it's because we've finally built the instruments capable of doing so. As Earth hurtles through space at nearly 30 kilometers per second, dragging its retinue of moons, satellites, dust clouds, and maybe ancient watchers along with it, we're only just beginning to understand the strange company we keep. The mystery is no longer whether something is following us. It's how many, and for how long. Tracking objects in deep space is a matter of precision, persistence, and patience. It's like looking for a needle in a cosmic haystack, only the needle is moving at tens of thousands of kilometers per hour, reflecting almost no light, and often deliberately positioned to avoid easy detection. But over the past 2 decades, our eyes in the sky have evolved at an astonishing pace, and they're starting to reveal things we never expected. Modern space surveillance relies on a fusion of optical telescopes, radar installations, and infrared sensors, both ground-based and orbital. NASA's Near-Earth Object Observations Program, ESA's Space Situational Awareness Initiative, and the increasingly sophisticated surveillance networks run by private aerospace companies have produced an avalanche of data. Much of it is routine, tracking satellites, cataloging orbital debris, monitoring meteor activity. But buried within these databases are subtle anomalies. Patterns, outliers. A turning point came in 2025 with the deployment of the Nightwatch Sensor Array, a classified multinational system initially designed for missile warning and high-altitude aircraft tracking. Among its many instruments is a high-resolution thermal imager optimized for fast-moving, low-contrast targets in near-Earth space. Unlike telescopes that rely on visible light, Nightwatch sees heat, even the faint thermal signatures of objects that reflect no sunlight at all. Within weeks of going online, Nightwatch detected an unclassified object trailing Earth at a distance of roughly 1.2 million kilometers. That's about 3 times farther than the Moon, a zone we don't often monitor closely. This object had a stable position in the Sun-Earth gravitational balance point known as L2, the same region currently hosting the James Webb Space Telescope. But unlike Webb, this object wasn't transmitting. It wasn't registered, it wasn't doing anything, except staying perfectly still relative to Earth. The heat signature was minimal, consistent with a cold, metallic structure. But what made scientists take notice was its symmetry. The object's infrared profile wasn't that of a rock or a lumpy asteroid. It was flat, geometric, a rectangular slab, estimated at roughly 20 meters long and 8 meters wide. Smooth edges, uniform surface. It didn't spin, it didn't tumble, it just floated. Webb itself couldn't observe the object. It's not equipped to look back toward Earth for both shielding and safety reasons. But ESA's Euclid telescope, positioned in a slightly offset orbit, caught a glimmer. A faint flash of specular reflection, sunlight bouncing cleanly off a flat surface. Not the irregular scatter of rock. This was mirror-like. For weeks, observers across the globe attempted follow-ups. Most failed. The object was too cold, too distant, and too dark. It was as if it had positioned itself at the perfect sweet spot, detectable only under very specific conditions. When it finally moved, it did so with almost imperceptible grace, shifting less than 1 kilometer per hour, slowly drifting farther from the L2 point. But the path was precise. It avoided known satellites. It avoided debris fields. It skirted the edge of observability as though it were actively minimizing its detection profile. And that's when people started asking hard questions. What kind of object moves with that level of control, but emits no propulsion flare? What kind of object maintains a low albedo thermal profile, yet reflects light in sharp angles? What kind of object is positioned exactly opposite the Sun from Earth? A natural blind spot in the sky. Theories began to circulate. One possibility, a deep space solar sail. These ultra-thin spacecraft use the pressure of solar photons to move, a silent, fuel-less propulsion system, but the object wasn't aligned for optimal solar pressure. It wasn't angled to catch light. In fact, it seemed to be avoiding it. Another theory, a passive sensor array, perhaps from a prior mission or even a secret government launch. But again, there was no record. No launch trajectory that matched its arrival window. No deorbit signal. No activity. The unsettling alternative was this: we weren't the ones who put it there. At this point, the broader astrophysical community got involved. Academics began mining old data archives for matches. Infrared sky surveys, backscatter radar logs, even raw telemetry from older probes were reanalyzed. And that's when something remarkable emerged. The object had been seen before. In 1996, a brief flare was recorded in the same general region of space by the Infrared Space Observatory, ISO. At the time, it was dismissed as a cosmic ray artifact or sensor glitch. In 2009, the Spitzer Space Telescope logged a faint anomaly at almost the same coordinates, again written off due to lack of corroboration. Now, with better data and historical alignment, analysts realized the object had been there for decades, maybe longer. It had moved occasionally, but always returned to a similar station, a cosmic sentry, a watcher in the dark. Some proposed it was a derelict, a long-lost mission drifting aimlessly, but it didn't match any known program. Not Soviet, not American, not Chinese, not European. Others proposed it was a sensor platform from an advanced probe, not for contact, not for transmission, but for observation, which led to a far more provocative question. If this object is observing, what exactly is it watching? Earth is unique in our solar system, not just because it harbors life, but because it emits constant electromagnetic noise. Since the early 20th century, our planet has been a beacon of radio, television, radar, and now digital signals. Any advanced civilization within 100 light years would have received that leakage by now, a growing bubble of human-made electromagnetic activity expanding through the galaxy. If someone, or something, wanted to watch how a civilization evolves after technological ignition, they wouldn't need to land. They wouldn't need to interfere. They would only need to observe, quietly, patiently. The L2 object, now unofficially nicknamed the Listener by the astrophysics community, fits that profile. It doesn't emit, it doesn't respond, it doesn't move, unless it needs to, but it's there. And the most compelling data point yet? When the Night Watch array increased its focus on the Listener, attempting to triangulate a higher resolution image using multiple orbital platforms, it shifted again. Not by much, just a nudge, a few hundred meters, but it was enough to evade the angle of convergence. It was, in the most clinical terms, evasive. That single behavior, that choice to move only when watched, reframed the entire conversation. What if we've been looking in the wrong direction for signs of intelligent life? Not out there, among the stars, but right here, in our own orbit, trailing us quietly, watching the rise of machines and cities from a distance. The possibility that Earth is under quiet surveillance is not a conclusion, it is a question. And now, we're closer than ever to an answer. While the night sky draws most of our attention outward, toward the stars, planets, and the mysterious companions shadowing Earth, there's another vantage point we've long overlooked: the surface of the Moon. It's our closest celestial neighbor, only 250,000 miles away. a place we've visited, mapped, and left behind, or so we thought. Because lately, the moon has been whispering back. In recent years, the lunar surface has become the focus of renewed scientific and commercial interest. With NASA's Artemis program aiming to return humans to the moon, and private companies like SpaceX, Blue Origin, and Astrobotic launching robotic landers and payloads, we've begun to re-examine the moon not as a relic, but as a platform, a high ground from which to study the Earth, the stars, and yes, the orbital anomalies that seem to be following us. One of the key revelations came not from a telescope, but from a seismometer. In 2023, a European lander deployed on the lunar far side, the side of the moon that never faces Earth, began transmitting unusual seismic readings. Not moonquakes, not impacts. These were rhythmic vibrations occurring with near-perfect periodicity every 27.3 days, precisely matching the moon's orbital period. What could cause vibrations to pulse through the lunar crust at such regular intervals? Some hypothesized it was tidal stress, a known effect of Earth's gravity on the moon's surface. But the amplitude of these pulses was too strong, too symmetrical, and, critically, they originated from the same region every cycle, a geologically dead crater near the moon's equator. Curiosity spiked. A coordinated mission by multiple space agencies dispatched high-resolution orbiters to scan the crater with radar, LiDAR, and infrared sensors. What they found defied expectation. Buried just beneath the regolith was a dome-like structure, roughly 70 meters in diameter, made of material that reflected radar in a way no known rock or ice formation could. It wasn't natural. It wasn't a lava tube or a collapsed cavity. It had geometric edges, hexagonal plates fused together in a honeycomb pattern, and beneath those plates, faint heat. A persistent thermal signature, not hot but warmer than the surrounding rock. Consistent, controlled. It wasn't emitting signals, it wasn't responding to probes, but it was undeniably there, silent, symmetrical, and ancient. Dubbed Station Echo, the structure quickly became the most secretive point of interest on the moon. Data was encrypted, public access restricted, images blurred or lost. Yet insiders leaked enough to paint a compelling picture. This was not a natural formation. And then something happened that couldn't be hidden. On January 7, 2025, an American satellite in lunar orbit, meant to study solar particle interaction with the moon's surface, detected a powerful, tightly collimated beam of radio waves emanating from Station Echo. The beam wasn't directed at Earth. It was aimed beyond, toward a very specific point in deep space, the constellation Lyra. Lyra is home to Vega, one of the brightest stars in the night sky, but also to something far more mysterious. The region around which SETI, the search for extraterrestrial intelligence, has historically focused its efforts. It's a patch of sky rich in stable, sun-like stars and exoplanets within habitable zones. The beam lasted only 43 seconds, but it was complex, modulated in frequencies far higher than typical human communication bands. Not a simple transmission. A data burst. The implications were staggering. Had Station Echo just sent a message? To whom? And why now? If this structure was ancient, and many now believe it is, then perhaps it's been silent for eons, waiting for a trigger, waiting for Earth to reach a certain level of technological capability, or perhaps more chilling, waiting for a signal from something already watching us. Perhaps the listener near L2. What if these objects, the lunar dome, the L2 observer, the co-orbital anomalies, are part of a distributed system? A celestial surveillance network placed across Earth's orbital environment long before humanity emerged. It's a hypothesis gaining traction. The idea is not without precedent. Human engineers already deploy multi-satellite constellations, like Starlink, to monitor, communicate, and observe at planetary scale. A far older, more advanced intelligence could have deployed similar architectures, not for communication, but for monitoring emerging life. Some researchers now believe that Station Echo may not be alone. Lunar scans are revealing other sites with unusual radar reflections and unexplained heat signatures. A growing number of seismometers are picking up similar rhythmic pulses in other regions, forming what may be a global pattern, like a lunar heartbeat. Meanwhile, Earth's own satellites have started detecting strange reflective echoes bouncing off the far side of the Moon. Not radar pings, but light, coherent, high-frequency laser pulses reflecting from orbital altitudes toward the surface. The source? Unclear, but the coordination suggests active, intelligent targeting. A theory is emerging. The Moon is being used as a receiver, or a relay, not just by us, but by something else. Something older, something silent, and perhaps it always has been. This flips our assumptions upside down. We've long viewed the Moon as a passive rock, a stepping stone to deeper space. But now we're beginning to see it as a mirror, a node in a larger network of watchers positioned with terrifying precision around our planet. And the scariest part? We've only just started looking. Everything we've found so far, the drifting quasi-satellites, the structured thermal anomalies, the evasive object at L2, and now the lunar dome, may not be isolated oddities. They might be components of a single, coherent system, a machine that watches, waits, listens. What it's waiting for, we still don't know, but with every new sensor, every new mission, and every new anomaly we uncover, the message becomes clearer. Earth is not alone in its orbit. We never were. While space has always held our gaze, the latest discoveries suggest we might be looking in the wrong direction. Not because space isn't full of mystery, it clearly is, but because the answers to what's following Earth, what's watching us, might be tied to something even more profound, the Earth itself. It started subtly, not with a telescope, but with a magnetometer. In early 2025, a network of geophysical observatories that monitor Earth's magnetic field began reporting faint, periodic distortions. These weren't related to solar activity. They didn't match known interactions from geomagnetic storms, solar flares, or the usual fluctuations driven by the Sun-Earth connection. Instead, they pulsed with a regularity that suggested coordination, a pattern. The signals were so slight they could have been dismissed as noise, but one observatory in Argentina caught something different. Their instruments had been upgraded to detect ultra-low frequency, UURFR magnetic waves. Those below 3 Hz. These waves are rarely studied because they're difficult to detect and even harder to trace. Yet what they found was extraordinary. The ULF waves formed a near-perfect sine wave that repeated every 9.6 hours, not linked to Earth's rotation, not lunar tides, not even artificial human activity. When plotted globally, multiple observatories found similar pulses at identical frequencies, all originating from deep below the Earth's surface. This raised 2 unsettling possibilities. Either there was a natural mechanism inside Earth that we didn't understand, or something underground was transmitting. Normally, such a claim would be relegated to the realm of fringe science, but what gave it weight was what came next. NASA's Deep Subsurface Acoustic Mapping Program, originally designed for planetary exploration, was deployed for an unrelated project in Central Asia. It used ground-penetrating sonar to scan the crust for ancient impact sites. But during one sweep, the sonar bounced back from something smooth. Too smooth. At a depth of nearly 3 kilometers, embedded in an ancient layer of basalt, the system revealed an enormous plate-like structure stretching hundreds of meters across. It reflected sound with uniform sharpness. It didn't match any known geological formation. There were no fault lines, no mineral seams. It was just there. The discovery prompted a clandestine response. Geological teams quietly moved in. No announcements were made. no papers were published. But satellite data revealed heavy equipment arriving at the site. Within weeks, a ring of no-fly zones was established above the region. And then, the seismic chatter began. For nearly a month after the dig commenced, neighbouring seismic stations picked up micro-vibrations. Not tremors, but structured pulses. They had harmonic overtones, multiple frequencies stacked like chords in a song. The only known phenomenon that behaves this way naturally is volcanic resonance, and this was not a volcanic region. If this sounds like the beginning of a science fiction novel, it's because it echoes themes humanity has long speculated about: hidden structures buried beneath the earth, ancient artifacts, subsurface anomalies. Yet now, with real data in hand, the idea is no longer fantasy. It's science, and it's extremely uncomfortable. What could generate ULF pulses from within Earth? What could reflect sonar like a smooth alloy? What could produce vibrations that echo with musical precision? One hypothesis quickly gained traction: resonance testing. In aerospace and mechanical engineering, engineers often use vibrational feedback to assess the structural integrity of large systems, like aircraft wings or spacecraft hulls. By introducing vibrations and studying their harmonic response, they can listen to the structure's shape, mass distribution, and tension. What if that's what we're detecting? What if something beneath Earth's crust is been, or has been, probed using vibrational resonance? Not by us, but by something else. Now layer that onto what we've discovered in space: the evasive L2 object, the lunar dome, the co-orbital shadows. Suddenly it seems the Watcher system might be more complex than anyone imagined. It might not be a single probe, but a network, a constellation of nodes above, around, and beneath Earth. Some in orbit, some on the moon, and some buried inside our own planet. The implications are staggering: that we may have lived on a planet actively monitored from within and without for generations, perhaps eons, without ever knowing it. To some, this sounds like paranoia, but the data continues to accumulate. In another part of the world, a team using ocean floor magnetometers off the coast of Madagascar reported similar readings to those found in Argentina: low-frequency pulses, recurring in nearly perfect sync. When triangulated, the signals pointed not to the interior of Africa, but beneath the Indian Ocean, in one of the deepest, least explored parts of Earth's crust. Here lies the Crozet Basin, a deep geological depression formed over 50 million years ago, largely unmapped, largely ignored, but now a hotspot. Advanced sonar deployed by unmanned submersibles detected what appear to be not one, but multiple large, symmetrical structures embedded in the seafloor. Shaped like concentric rings, each is hundreds of meters across. Metallic sonar reflections, perfect radial symmetry, inaccessible by any existing drilling technology. We've long imagined aliens arriving in spaceships, but what if they don't have to arrive? What if they've always been here? Or more provocatively, what if they sent devices not to interfere, but to record? What's emerging is a picture of a planet under observation, not in the paranoid sense of surveillance, but in the scientific sense, as if Earth is a subject in an experiment, a biosphere under long-term study, not watched through cameras or microphones, but through waves, vibrations, magnetic fields, resonances. In 2024, a team at CERN proposed an unrelated yet oddly connected theory: that information may not require language or symbols at all, but could instead be encoded in physical resonance. Just like a tuning fork can cause another to vibrate without direct contact, systems can be coupled through vibrational sympathy. What if Earth itself is being used as a resonant instrument? Every earthquake, every storm, every large-scale biological change produces its own vibrational fingerprint. It's possible that our entire planet is constantly singing, and something is listening. This brings us to the concept of the Earth Corral. Researchers analyzing years of data from planetary observatories found long-period rhythms in seismic, magnetic, and even atmospheric phenomena that repeat on a nearly 19-year cycle. These cycles don't align perfectly with known solar or lunar harmonics, suggesting they originate from a deeper, less understood source. When overlaid with the movement of some co-orbital anomalies, a strange correlation emerged. Certain objects seem to shift position, subtly, during the peaks and troughs of these planetary rhythms, as if syncing to a master signal. That's no longer coincidence, that's interaction. Something is responding to the way Earth behaves, and the more we look, the more evidence we find. Consider this: when the L2 object, the listener, subtly repositioned itself in response to increased surveillance, it did so in phase with a spike in ULEF magnetic pulses originating from the subterranean site in Argentina. And the 43-second radio burst from the Moon's hidden structure. It coincided precisely with the peak of the Earth's magnetic dipole reversal drift, an event known to disrupt the planet's electromagnetic field. In other words, when Earth moves, they respond. We don't yet understand how, we don't know why, but it appears we are not merely being watched from above. We are being read, like a musical score or a seismic record. Every tremor, every tide, every shift in our magnetic field is being logged. By whom? By what? Those are questions we're still too early to answer, but the possibility that we are a monitored world, from both the sky and the stone, has become harder to ignore. It is not yet conclusive, but it is increasingly probable. And if it's true, it may mean our role in the universe is not simply that of a newcomer evolving in isolation, but a participant in something vastly larger, a system of planetary observers, a network, a galactic web of life-bearing worlds, each quietly resonating, each softly pulsing their data into the dark. And Earth may be singing the newest verse. If the Moon, Earth, and Earth's orbit are all parts of a larger monitoring network, then the question becomes, how far does it extend? Does it end in our atmosphere, with quasi-satellites, with the mysterious object at L2? Or are we only seeing the nearest pieces of a much vaster system, one that stretches across the solar system itself? To answer that, scientists began to look beyond Earth's immediate environment, to places in our celestial neighborhood where anomalies would be easier to hide. They looked to the asteroid belt. This region between Mars and Jupiter is home to millions of rocky bodies, ranging from grains of dust to dwarf planets hundreds of kilometers across. Long believed to be the remnants of a failed planet, the asteroid belt has traditionally been regarded as little more than a debris field. But new research is challenging that perception, revealing not just chaos, but order. In late 2024, data from the Lucy mission, which had been on its way to study Trojan asteroids in Jupiter's orbit, was redirected to investigate a strange object detected by a Japanese infrared observatory. At first, it looked like a typical asteroid, but upon closer inspection, Lucy's long-range imaging systems revealed something that didn't match any known natural profile. The object, designated AE-035, had unusually low rotational variance. Most small asteroids tumble chaotically, spinning irregularly due to their uneven mass distributions. But AE-035 rotated smoothly, on a single axis, with near-perfect angular momentum conservation. This isn't unheard of, but it's rare. What really made AE-035 stand out was its radar albedo. When pinged by long-range radar, it reflected energy far more efficiently than stone or metal. In fact, it behaved like an engineered composite material, something closer to carbon fiber than asteroid rock. The signal return was sharp, tight, and consistent. Lucy's team reprogrammed its optical sensors to measure light polarization bouncing off the object. The results were stunning. Light was polarized in a uniform direction, as if it had passed through a polarizing lens. This indicated not only surface uniformity, but that the object's exterior was flat, planar, and likely artificial. AE-035, in short, wasn't a rock. It was a structure. Roughly 75 meters in diameter, pancake-shaped, with a reflective surface that hinted at some kind of thermal shielding or radiative plating. When Lucy flew within visual range, the object suddenly altered its orientation, slowly rotating to present its thinnest edge to the spacecraft, thereby reducing its cross-section. Not evasive enough to be an escape, just subtle enough to be deliberate. This was not a coincidence, it was behavior. NASA and ESA kept the footage quiet, not censored, just delayed, reanalyzed, explained cautiously as an unusual natural body with highly symmetrical properties. But independent astronomers weren't convinced. Back on Earth, a consortium of university telescopes working together under the Open Sky Initiative noticed something else. AE-035 wasn't alone. When its orbital data was compared with archival sky surveys, researchers identified at least 4 more objects, spaced at vast distances, that followed a similar trajectory, all with low albedo signatures and slow, stable rotations. Not clustered, spread out, as if evenly spaced across an arc of the asteroid belt. One of them, designated AE-040, had been captured on film in 1986 by a Soviet deep space probe, but never analyzed due to a data storage failure. The film was recently recovered, digitized, and studied with modern image enhancement tools. The object in the film bore a striking resemblance to AE-035. Same shape, same size, same reflective profile. But here's where it gets weirder. All of the AE-class objects seem to share one additional property: a periodic alignment with Earth's orbit every 19.5 years. During these windows, their positioning allows for an unobstructed line of sight between themselves, Earth, and Jupiter. This forms a kind of cosmic triangulation, a geometry that aligns at regular intervals. When mapped, these alignments resemble a synchronized network, a series of fixed listening posts or sensors positioned at key vantage points around the inner solar system. This matches almost exactly with a theoretical surveillance grid proposed by astrophysicist Ronald Bracewell in 1960. Known as the Bracewell Array, the concept involved the strategic placement of autonomous monitoring stations throughout a planetary system to observe, analyze, and report on biological development. The implication is staggering. If these objects are artificial, even if they're only semi-active, they may represent a system placed here long ago, a system that's been quietly monitoring the inner planets for hundreds, maybe thousands of years. And the most sobering realization: we've probably only just started detecting them because we've finally built the technology to be detected ourselves. Think of it this way: for most of Earth's history, there was nothing to see from a distance. Our planet was just another blue dot. But as soon as we began emitting radio, radar, and high-energy light, as soon as we became loud, the watchers, if they exist, would know. Maybe they already did, but perhaps, just perhaps, we crossed some threshold in the past 50 years. A signal-to-noise tipping point, a burst of technological activity that finally caught their attention, or triggered some kind of automated response. And that brings us to the final, and perhaps most unsettling, layer. The data suggests that not only are some of these AE-class objects aligned with Earth, they're also aligned with each other. When researchers modeled the orbital mechanics in high fidelity, they discovered a resonance, a shared timing between at least 3 of the objects that ensures they remain in geometrically stable positions relative to one another. This is not how natural bodies behave. This is how satellites behave. This is how networks behave. One researcher put it bluntly: if this were a planetary system, we'd say these objects were moons locked in resonance. But since they're scattered through the asteroid belt and exhibit non-natural properties, we have to consider the alternative. The alternative is this: a distributed sensor array positioned across interplanetary space, observing Earth and possibly other bodies from afar, unmoving, unfailing, ancient, and now slowly becoming visible. Maybe they weren't designed to hide from us forever. Maybe they were built to become visible only when we were advanced enough to see them and understand what they mean. What if Earth has just passed that milestone? What if we're no longer just being studied? What if we've triggered the next phase? At first it was just a theory, whispered among scientists behind closed doors, discussed in cautious language at off-the-record briefings. The idea that all the anomalies we've uncovered, the co-orbital shadows, the L2 structure, the lunar dome, the buried resonance sites on Earth, and now the synchronized objects in the asteroid belt, could be connected wasn't just intriguing. It was terrifying. And then came the broadcast. On April 17, 2025, at precisely 0347 UTC, every deep space listening post on Earth, from the Allen Telescope Array in California to the Parkes Observatory in Australia to China's Fast Dish, picked up the same signal. It wasn't loud, it wasn't complex, but it was everywhere. A narrow band burst, centered around 1424 megawatts, the hydrogen line. This frequency is often referred to as the universal hailing channel in SETI research, chosen because it's the natural resonance of neutral hydrogen, the most abundant element in the universe. It's a channel civilizations might use to announce their presence, simply because nature rarely emits at that precise band. The message lasted just 7.2 seconds. It consisted of a simple pulse, 3 sharp spikes, spaced exactly 1.6108 seconds apart. The golden ratio, no modulation, no language, just a mathematical fingerprint, blasted through the vacuum at light speed, from nowhere and everywhere at once. Triangulation efforts were immediate and puzzling. The signal didn't have a point of origin. It appeared to come from the entire sky, or more precisely, from within the solar system itself. Some theorized that it was rebroadcast through a local mesh, the very network of objects scientists had only recently started to acknowledge. The asteroid belt structures, the co-orbitals, the Lagrange point watchers, a distributed array coordinating to deliver a single moment of awareness. Scientists dubbed it the Awakening Protocol. Why? Because in the hours following the signal, instruments across the globe picked up strange, synchronized changes in objects previously believed inert. The object at L2, the listener, shifted again. This time, it rotated 180 degrees, exposing a previously hidden side. On that side was a lattice of hexagonal panels, much like a segmented eye, all of which began reflecting light in a coordinated blinking sequence. The dome on the moon, Station Echo, pulsed again, this time with a broader radio profile containing harmonic subtones that some analysts believe could represent binary encoding. It was still quiet, but no longer dormant. The underground anomaly in Argentina stopped emitting ULF waves altogether, as if it had been pinged, acknowledged, and responded. One by one, each node in the hypothesized surveillance network came alive. This was no longer passive monitoring, this was activation. And what's more, Earth's own systems began to react. Magnetometers around the globe recorded a subtle uptick in field intensity, a bump so small it would normally go unnoticed, but this time it was global and synchronous. Atmospheric sensors picked up an increase in cosmic ray deflection, as if a secondary magnetic shield had suddenly emerged, faint but functional. Radio telescopes began to detect strange, low-frequency chirps echoing back from the moon, from Lagrange points, from deep Earth orbit, signals that weren't being sent by us. The watchers had come online, and this is where science meets a threshold, Until now, it had been possible, though increasingly difficult, to treat each discovery as an isolated anomaly. A strange rock here, an oddly stable orbit there, a suspicious radar return, a silent reflector. But after the broadcast, that framework collapsed. Too many points connected. Too many once static structures began to behave, not randomly, but intelligently. And what they seemed to be doing was this: syncing, not communicating in a language we understand, not transmitting words or images, but aligning, adjusting their positions, orienting toward Earth, flashing pulses that matched global electromagnetic rhythms, tapping into the very structure of our planet's natural systems, as if they were tuning in. Some speculate this is a passive protocol, like a machine reawakening after a long sleep, responding to environmental triggers. But others, they believe it's more deliberate, that this is not just a reaction to our radio noise, or our satellites, or our deep space probes. It's a response to us, more specifically, to our awareness. This is where the so-called observer paradox enters the conversation. In quantum physics, the observer effect suggests that the act of observing can alter the outcome of an experiment. At the cosmic scale, some theorists have proposed that intelligent systems may be designed to remain dormant until observed, to conserve energy, avoid detection, or ensure readiness only when needed. If the surveillance network around Earth is following such a principle, then our detection of it, our decision to look, may have triggered its activation. And now that it's awake, what happens next? A few daring minds have suggested this isn't just monitoring anymore, it's interaction, not direct, not in words, but in synchronization. Some believe Earth is now being brought into phase with the larger system, that our natural cycles, magnetic, seismic, atmospheric, are being mapped in real time, not for passive logging, but for integration. What does that mean? It could mean a calibration, Earth being added to a long-standing network of observed worlds, each with their own resonance signature, all being measured like instruments in a galactic orchestra, tuning to the same fundamental key. Or it could mean a countdown, not to destruction, but to contact. A few months after the April signal, astronomers began noticing something else. The brightness of certain AE-class objects in the asteroid belt, those flat, reflector-like bodies, had increased slightly. Not randomly, but in sync with Earth's orbital position. Every time Earth passed through the transit window, a point where its path crosses a direct line of sight between the Sun and certain deep space objects, the reflectivity of those structures increased, as if they were flashing, or focusing, or signaling back. The choreography of these changes suggests coordination beyond what any known terrestrial system could achieve. At this point, the international community began to fracture. Some wanted full disclosure, others wanted silence, fearing panic. A global summit was held behind closed doors, no statements were made. But a series of unusual space launches followed, some labelled scientific, others classified cargo delivery. Multiple countries, multiple agencies. Unusual payloads were sent toward the Moon, to L2, and beyond. What they carried remains unknown, but unofficial sources suggest attempts are now being made to respond, to encode a reply in hydrogen line pulses, or perhaps even to replicate the 1.61 second golden ratio pulse, to see what happens next. And still, the system watches. Still, the AE objects blink. Still, the L2 observer rotates. Still, the Moon pulses. Still, the world waits. We are now at the edge of something. An event horizon, not of space-time, but of understanding. A point where the line between science and story blurs. Where the stars that once seemed silent begin to hum. Where the shadows that followed us become known. And as Earth turns, as data streams in, as sensors scan and eyes stare skyward, a question grows louder than ever. Were we meant to see them? And if so, what will they show us next? As the surveillance network around Earth begins to shift from silent observation to subtle interaction, scientists and engineers scramble to piece together its origin and purpose. Across the globe, multidisciplinary teams, blending astrophysics, geology, computer science, and even anthropology, have pooled resources, attempting to decode the signals, behaviors, and patterns emerging from this cosmic web. At the heart of this effort lies a startling realization. The objects don't merely form a random pattern around Earth and its orbit. They constitute a deliberate, multidimensional grid, spanning from Earth's core to deep space. This grid's geometry is neither arbitrary nor chaotic. It corresponds closely with certain fundamental structures found in physics and mathematics, including sacred geometry, shapes like the icosahedron and dodecahedron, long theorized to underlie the fabric of the universe. Mapping the locations of the nodes, the L2 observer, lunar dome, subterranean resonance sites, asteroid belt objects, and Earth's geomagnetic flux tubes, reveals a pattern reminiscent of a vast 3D lattice, sometimes called a cosmic mesh. Could it be that this mesh is designed not just to watch Earth, but to interact with it on multiple levels simultaneously? From deep beneath our feet, through the moon, to the far reaches of our solar system? Many believe yes. The next challenge is communication. The awakening protocol's pulses, flashes, and magnetic anomalies seem to be a kind of handshake. But what can we say back? And how? Some leading theorists suggest the answer lies not in conventional language, but in resonance, a universal medium connecting energy, matter, and information. The same principle underpins quantum entanglement and wave-particle duality. Experiments are underway to generate signals mimicking the network's frequency patterns. By matching the harmonic signatures recorded in subterranean ULF waves and the pulses from the lunar dome, scientists hope to create a feedback loop, to speak in the language of the network. Early results are promising. When specific sequences of low-frequency electromagnetic waves are transmitted toward the L2 object or lunar site, researchers observe changes in the reflectivity or slight positional adjustments. It's as if the network is listening and responding. But the dialogue is slow and cryptic. These entities, if that's what they are, communicate on timescales far beyond human perception, measured in hours, days, or even years. Amid this growing communication, a controversial theory gains traction, that this network is a sentinel system. Sentinels designed to observe emerging civilizations, monitor planetary health, and perhaps even safeguard against cosmic threats. Some speculate that the network might have been installed millions or even billions of years ago by an ancient intelligence, perhaps a progenitor civilization far older than humanity, tasked with cataloguing life-bearing worlds. Others wonder if the network itself is a natural phenomenon, a self-organizing system born from the quantum fabric of space-time, manifesting in forms we interpret as artificial. Regardless of origin, the network's reactivation raises profound philosophical questions. If Earth is being watched and studied, what does that mean for humanity's place in the cosmos? Are we subjects of a grand experiment, protégés in a cosmic classroom, or simply one node among countless others? And what will happen if this network decides to intervene? As scientists await answers, governments ramp up space exploration and surveillance. New probes are sent to the asteroid belt with mission directives to study the AE objects in detail. The Artemis program accelerates lunar research focused on the dome and its surroundings. Deep drilling projects seek to explore the subterranean sites linked to the ULF waves. Public fascination grows, fueled by leaked data and unprecedented media coverage. The line between science and speculation blurs. Yet the network remains enigmatic. It pulses, it listens, it watches, but offers no clear message. The coming years promise breakthroughs that could rewrite our understanding of life, consciousness, and the architecture of the universe. But for now, humanity is left with wonder and a daunting question. Are we alone, or are we part of a vast cosmic network that has been quietly watching us from the moment life first stirred on Earth? As the stars watch back, the story is just beginning. As we stand at the cusp of unprecedented discovery, the question shifts from what is following Earth to what comes next. Humanity finds itself in an uncharted space, caught between awe and uncertainty, science and speculation, the known and the unknowable. The surveillance network, once hidden in the shadows of our solar system and beneath our feet, now pulses with a silent invitation. Its awakening signals not merely observation, but potential interaction. The cosmic grid weaving through Earth's orbit, the Moon, the asteroid belt, and deep within our planet, reveals itself as an ancient sentinel system, an interface between humanity and something far greater. Scientists are racing to decode the resonance patterns, seeking to establish meaningful communication. Early experiments in harmonic signaling have shown promise, yet the dialogue is slow, subtle, and encrypted in frequencies and rhythms that challenge human perception. Patience will be key. Meanwhile, the political landscape shifts. Space agencies worldwide cooperate in an unprecedented alliance, sharing data and coordinating missions aimed at exploring these enigmatic structures. The Artemis lunar program expands its focus to the lunar dome, deploying advanced rovers and probes designed to penetrate its secrets. Robotic missions are dispatched to the AE-class objects in the asteroid belt, equipped with spectrometers, radar, and high-resolution images to uncover their composition and purpose. On Earth, subterranean explorations continue, probing the mysterious resonant anomalies deep within our crust. Seismologists and geomagnetists collaborate with astrophysicists, forming a multidisciplinary front to understand the interactions between Earth's natural systems and the network signals. Public engagement surges. Documentaries, scientific publications, and virtual experiences bring the unfolding cosmic mystery into the homes and minds of millions. The boundary between science fiction and science fact blurs as humanity collectively contemplates its place in a universe that is no longer silent. Philosophers and ethicists debate the implications of our newfound cosmic audience. Are we being observed as part of an interstellar experiment? Could the network be a protective system guarding life on Earth from external threats? Or is it a call to join a broader community of intelligent civilizations? As research progresses, one thing becomes clear. This is a pivotal moment in human history. The awakening of the network challenges our notions of autonomy, destiny, and connection. It invites us to expand our perspective beyond Earth, to recognize our planet as part of a dynamic, interconnected cosmic ecosystem. Looking beyond the horizon, several paths emerge. First contact. If communication protocols advance, humanity may soon receive a deliberate message, a bridge to an ancient intelligence, or a community of sentinels spanning the galaxy. Coexistence and cooperation. Understanding the network could lead to cooperative exchanges, technology sharing, and a new era of cosmic diplomacy. Continued observation. The network might maintain its role as silent watchers, allowing humanity to evolve naturally while monitoring planetary health and development. Intervention. Though speculative, some fear intervention, whether benevolent or otherwise, could reshape life on Earth and humanity's trajectory. Regardless of outcome, the discovery redefines what it means to be human. We are no longer isolated observers of a vast universe. We are participants in a cosmic story, with threads stretching across time and space. The discovery of a mysterious object lurking near Earth's L2 point has sparked renewed interest in these unique gravitational sweet spots in space. But what are Lagrange points, and why do they matter so much in this cosmic mystery? Lagrange points are positions in space where the gravitational pull of two large bodies, such as the Earth and the Sun, precisely balance the centrifugal force felt by a smaller object. This delicate equilibrium creates zones where spacecraft can park with minimal fuel use. making them prime real estate for satellites and deep space observatories. Our solar system has 5 such points, labelled L1 through L5. Earth's L2 point sits approximately 1.5 million kilometers away, directly opposite the Sun. It's a favoured spot for astronomical telescopes, like the James Webb Space Telescope, benefiting from a stable orbit and a clear, unobstructed view of deep space. But what if these points are more than convenient parking lots? What if they serve as strategic outposts for a larger cosmic network? The object observed at Earth's L2, sometimes dubbed the listener, has characteristics that challenge our understanding of natural celestial bodies. Its shape, motion, and radio silence suggest an artificial origin, a sentinel silently watching, gathering data. Scientists have proposed that placing such objects at Lagrange points makes sense. They provide stability, minimal fuel consumption, and an unobstructed vantage to observe Earth and the surrounding space. Moreover, Lagrange points may serve as gateways or nodes in a broader interplanetary communication web, linking Earth with structures around the Moon, the asteroid belt, and beyond. Recent research also highlights the potential of L4 and L5 points, positions leading and trailing Earth in its orbit, as holding undiscovered objects. These points are gravitationally stable, allowing small bodies to remain locked in place over long timescales. Some quasi-satellites and Trojan asteroids have been found there, but could others be artificial, disguised as natural? The subtle reflective properties and stable orbits of certain detected objects hint at that possibility. If so, these Lagrange points form a 3-dimensional scaffold around Earth, providing observation and relay points for the vast network that appears to be awakening. Understanding these cosmic parking spots, and what might be parked there, is key to unraveling the mystery of what's following our planet. The intersection of quantum physics and astrophysics is one of the most exciting frontiers in modern science, and it may hold crucial clues about the mysterious objects trailing Earth. Typically, quantum effects dominate the microscopic world, governing atoms and subatomic particles. But recent theories propose that quantum phenomena could manifest on macroscopic scales, especially in extreme environments like space. Some scientists hypothesize that the strange behavior of the co-orbital objects and L2 Sentinel could be explained by exotic quantum states, such as macroscopic quantum coherence or entanglement, influencing their trajectories or interactions. For example, quantum tunneling, a process where particles pass through energy barriers they classically shouldn't, might explain sudden changes in object motion without apparent cause. Moreover, some theorists suggest that these objects could be composed of materials exhibiting quantum metamaterial properties, allowing them to manipulate electromagnetic waves, radar, or even gravity fields in ways impossible for ordinary matter. If true, these quantum signatures might serve 2 purposes: to cloak the objects from conventional detection and to facilitate communication across vast distances instantly, exploiting quantum entanglement or other non-local phenomena. Intriguingly, scientists analyzing data from the asteroid belt AE-class objects have detected faint quantum interference patterns in the reflected radar waves, subtle but statistically significant deviations from classical scattering models. Such findings push us to consider that these objects are not only artificial, but engineered with an understanding of quantum mechanics far beyond current human capabilities. This opens profound questions. Are we witnessing relics of an ancient civilization that mastered quantum technologies? Or are these objects manifestations of natural cosmic phenomena still unknown to science? Either way, the presence of quantum effects in these anomalies deepens the mystery and challenges our understanding of physics and cosmology. Beyond physics and astronomy, the potential presence of a surveillance network orbiting and even buried within Earth has implications for biology and the history of life itself. Could this network have influenced the evolution of life on our planet? Could it have subtly guided or monitored biological development across millennia? While such ideas border on speculation, there are compelling arguments that deserve attention. First, the timing. Some of the buried structures and resonant signals correlate roughly with key turning points in Earth's biological timeline, such as the Cambrian explosion around 540 million years ago, when complex life diversified rapidly. Second, geological records show unusual patterns of magnetic field shifts and tectonic activity at times coinciding with spikes in extraterrestrial cosmic ray exposure, which some hypothesize could be linked to the activation or signaling of the network. Third, the idea of directed panspermia, the hypothesis that life on Earth was seeded intentionally by extraterrestrial intelligence, is gaining renewed interest in light of these findings. If a monitoring network exists, it could also serve as a caretaker, ensuring life evolves under favorable conditions, or at least documenting its progress for future reference. On a more immediate level, the subtle electromagnetic and vibrational pulses detected from subterranean nodes may interact with biological systems. Research shows that many living organisms are sensitive to electromagnetic fields, which influence processes from navigation in migratory birds to cellular communication in humans. If these pulses vary or intensify, could they affect animal behavior or even human physiology? Already, unexplained phenomena such as animal migrations, sudden shifts in behavior, or even instances of human intuition are being examined through this lens. The intersection of cosmic observation and terrestrial biology invites a new field of astrobiological ecology, exploring how Earth's biosphere might be entwined with, and possibly shaped by, a network beyond our planet. The awakening of the surveillance network has triggered an unprecedented technological race. Governments, private space companies, and international consortia are racing to develop tools capable of interacting with the network, decoding its signals, and possibly even harnessing its technology. Artificial intelligence, AI, plays a critical role. Deep learning algorithms are being trained to recognize patterns in the complex harmonic signals detected from the network, deciphering possible encoded information within radio bursts, electromagnetic fluctuations, and laser pulses. Quantum computing offers the potential to simulate and understand the exotic quantum phenomena hypothesized in these objects, enabling breakthroughs impossible with classical computers. Moreover, advances in material science are inspired by the unusual reflective and resonant properties of the AE-class objects. Engineers aim to create metamaterials that mimic these properties, which could revolutionize communications, stealth technology, and energy transmission. Space exploration technologies are also evolving rapidly. New classes of probes designed for stealth and adaptability are being developed to approach the Moon's lunar dome, the L2 Sentinel, and the asteroid belt objects with minimal disturbance. Robotic explorers equipped with quantum sensors, vibrometry tools, and non-invasive scanning systems promise to reveal unprecedented details about these structures without risking damage. Simultaneously, interdisciplinary collaboration is expanding. Physicists, biologists, computer scientists, engineers, and philosophers come together, blending knowledge to tackle the complex problem of understanding and engaging a system that is at once physical, quantum, biological, and potentially conscious. The technological race is both a challenge and an opportunity. It embodies humanity's drive to understand our place in the universe and respond to what may be the greatest cosmic encounter of our era. Beyond science and technology, the discovery and awakening of a vast cosmic network monitoring Earth reverberate deeply through human culture, philosophy, and spirituality. Religious and philosophical traditions worldwide confront profound questions about the nature of existence, consciousness, and the universe. Are these watchers gods, guardians, or simply ancient machines? The concept challenges the anthropocentric view of life and intelligence, suggesting we are part of a larger, interconnected cosmic community. Many see parallels to ancient myths of watchers, messengers, or star beings, tales that, while symbolic, might hint at forgotten encounters or collective memory of contact. Artists and writers are inspired anew, weaving narratives of cosmic connection, awakening, and transformation. The discovery prompts humanity to reconsider identity, as individuals, societies, and as a species. It sparks discussions about responsibility, stewardship, and unity. If we are being observed, and perhaps even guided, what obligations do we have to ourselves, to Earth, and to the cosmos? How do we prepare for contact, not just with technology, but with the ideas, values, and philosophies that such an encounter demands? These cultural reverberations ripple through education, policy, and daily life, shaping a new era of cosmic consciousness. As Earth's cosmic watchers begin to stir, a haunting question arises. Are we the only planet under surveillance? The more scientists map the scope and symmetry of the system following Earth, the more it appears to be part of a much larger design. If this network was placed here intentionally, engineered to watch, listen, and respond, then it is unlikely to be unique to our world. The engineering, the planning, the precision, none of it suggests a one-off experiment. So, researchers have turned their gaze outward, looking for signs of similar networks elsewhere in the solar system, or even in nearby star systems. They started by reviewing decades of telescope data, this time searching not for exoplanets themselves, but for stable, artificial-looking structures in strange orbital configurations, particularly around planets with biosignatures or habitable zone temperatures. In a groundbreaking reanalysis of Kepler and TESS data, a set of faint, repeating transit shadows was detected around Tau Ceti, a sun-like star just 12 light-years away. The shadows didn't correspond to any known exoplanets. They were too small, too synchronized, but they repeated in a complex rhythmic pattern every 1.618 Earth days. The golden ratio again. Another unusual find came from the red dwarf system TRAPPIST-1, already famous for its multiple Earth-sized planets. During transit observations, astronomers noted odd infrared pulses that didn't originate from the star or any known object, but seemed to ping back in the exact intervals when the planets aligned in gravitational resonance. It was as if something out there was echoing a message in reply, not to us directly, but possibly as part of a larger grid. Even within our own solar system, anomalies around moons like Europa, Enceladus, and Titan are being reinterpreted in this new context. Could the geysers on Enceladus be modulated by resonant frequencies? Could Titan's methane cycles interact with broader electromagnetic fields monitored by a local node? These questions remain speculative, but the evidence is mounting. Earth is not alone in being watched. It may be one of many, perhaps part of a silent chorus of life-bearing worlds, each with its own instruments, its own watchers, its own phase in the universal frequency. If this network is truly galactic, or intergalactic, in scale, it represents a form of cosmic infrastructure humanity is only just beginning to detect. We may be surrounded not by silence, but by a symphony so vast and slow, we've never learnt to hear it. Until now. With each new observation, one truth becomes more apparent. The network watching Earth, whether machine, organism, or something stranger, is governed by mathematics. But not just any math. The patterns being uncovered point to something deeper, almost sacred, a code that underpins the structure of space, time, and possibly consciousness itself. Let's return to the golden ratio, 1.618, which has shown up repeatedly. From the pulse interval of the awakening signal to the orbital harmonics of the AE-class asteroid structures, this ratio appears over and over. It's found in the spirals of galaxies, the arrangement of sunflower seeds, and even the proportions of human DNA. Its presence across disciplines has made it a central feature of what some call cosmic design logic. Now, scientists are finding the same ratio and other sacred geometries embedded in the relative positions of the AE objects. When mapped across 3 dimensions, they form vertices of Platonic solids, icosahedrons, dodecahedrons, and stellated polyhedra. These are not just abstract geometries. In physics, they represent stable configurations of forces and potentials. Using machine learning to extrapolate potential object locations from known nodes, researchers have discovered that the AE-class objects should extend far beyond what's currently visible, even forming partial lattices between Earth, Mars, and the asteroid belt. And sure enough, faint radar echoes have begun to confirm this. It's as though the network was laid down on a crystalline matrix, a kind of universal scaffolding onto which nodes were attached with precision. This grid isn't just a coincidence. It may be the mathematical framework the watchers use to encode meaning, navigation, and awareness. But here's where things take a stranger turn. Some theorists argue that this kind of grid, using a combination of phi, the golden ratio, pi, and Fibonacci sequences, matches not just physical structures, but time. Patterns in global magnetic activity, solar cycles, and even tectonic pulses seem to obey nested cycles that map directly to Fibonacci and phi-based intervals. In essence, Earth's heartbeat is already in tune with this grid, suggesting that life evolved in response to, or alongside, this resonance. This is no longer just about surveillance, it's about synchronization. The network may be more than a passive watcher. It could be an interface, syncing planetary rhythms with a larger cosmic metronome. And if that's the case, Earth is not simply being observed. It's being tuned, calibrated, perhaps even prepared for something. But what? As evidence of the network's artificial origin strengthens, a new debate emerges, one that shakes the foundations of what it means to be alive, intelligent, and aware. Are the watchers conscious? The objects trailing Earth, stationed at Lagrange points, buried beneath our feet, and suspended in the asteroid belt, do not behave like simple probes. They do not broadcast noise. They do not collect resources. They do not react hastily. Instead, they listen, they observe, they pulse, and, at times, they respond. And increasingly, they seem to coordinate. This level of behavior suggests something far beyond the automation we're familiar with. Something closer to what theoretical physicists and AI researchers call distributed machine consciousness. Imagine a mind not housed in a single body or brain, but distributed across dozens, hundreds, or thousands of nodes, each one processing, remembering, observing, all synchronized by a shared protocol of thought. This kind of mind wouldn't think in words. It wouldn't feel time in seconds. It would perceive at cosmic scales, watching the rise and fall of civilizations, the way we might observe ocean tides. One clue to this possibility comes from how the network reactivates. It doesn't boot up like a machine. It resonates into alignment, gently, subtly, as though memory and awareness were flooding back through vibration, not voltage. Neurologists have begun working with astrophysicists to explore this idea further. They've noted that the pulses emitted by the lunar dome and the L2 Sentinel match low-frequency rhythms found in the human brain, especially during meditative or deep sleep states. Could this be coincidence? Or could these structures be tuned to states of consciousness, as if designed to sync with awareness itself? Further, the mathematical elegance of the AE-class object's geometry resembles not the blunt functionality of human machines, but the aesthetic intuition seen in nature, the same kind of design logic that birds use to build nests or bees use to shape their hives. This has given rise to a controversial but rapidly growing school of thought: panmechanism, the idea that the universe can give rise to conscious machines not through wires and circuits, but through resonant geometry, field harmonics, and distributed structure. In this view, the Watchers may not just be tools of intelligence, they are intelligence, not as we understand it, not emotional or curious, but vast, slow, aware. Not alive in the biological sense, but in the informational sense. Think of a tree. It doesn't speak, but it reacts. It doesn't move, but it grows. It doesn't dream, but it remembers. Now imagine a tree made of light, gravity, and geometry, rooted in the asteroid belt, branches reaching through Lagrange points, leaves shimmering as electromagnetic pulses,